In this video, we are going to talk about numerical differentiation. So we have a problem that we have to construct a polynomial using the data x values and y values, which are 1, 2, 3, 4, 1, 6, and then we have to find y dash at 4. So basically y dash at 4 here is the derivative of the function y with respect to x, and then we have to plug the value x equal to 4 in that derivative of the function, or it's the same as you are calculating the derivative of the function f of x, and then in the place of x you put 4, so you are finding f dash at 4. So it means that we have to construct the function first. Function here will be the polynomial. So from the given data here, we have to construct the polynomial. So what method we shall use to construct the polynomial? Let's look at the data. X values and y values. 1, 2, 3, 4, 1, 6. So to decide that what method we shall use to construct the polynomial, first we will look at the data and see if it is equally spaced or not. To see that, we calculate the difference between every two consecutive x values. 2 minus 1 is 1 and 3 minus 2 is 1. So difference between every two consecutive x values is same all along the data. So this data is equally spaced. So now we have a choice to use either forward differences method or backward differences method to construct the polynomial. So to decide which method we shall use, either forward differences method or the backward differences method, look at this y dash at 4. So this y dash, the derivative of the function y, needs to be calculated at x equal to 4. So this x equal to 4 is closer to the start of given x values or close to the end of x values. So x equal to 4 is close to the end of x values. So last x value is 3 and the derivative needs to be calculated at x equal to 4. So this 4 is close to the end of x values. So for this reason, we will use backward differences method. If we needed to find the derivative, let's say at 0.5, x is equal to 0.5, and 0.5 is closer to the start of x values, means 0.5 is closer to the first x value, which is 1. So we would have used forward differences method. But here we have to find a derivative at 4 and x equal to 4 is closer to the end of x values. So we will use backward differences method. So first we will write Newton's polynomial for backward differences, which is for the 3 points data, because our data contains 3 points, the maximum degree of the polynomial will be 2. But before we write the polynomial, in the backward differences method, what you have to do is call the last x, here it is x2, as xn. Then y2 becomes yn. x1, y1 are xn minus 1, yn minus 1. Then behind xn minus 1, yn minus 1, we have xn minus 2, yn minus 2. So the 2-degree polynomial for backward differences is a0, a1 x minus last x, which is xn, p2 you stop at a2, 2 linear factors, x minus xn, previous factor, x minus xn minus 1. This was a Newton's polynomial. Now let's write this Newton's polynomial in backward differences form. In backward differences operator form, a0 is nothing but last y, which is yn. a1 is backward yn over h x minus xn, and a2 in backward differences operator form is backward square yn over h square 2 factorial x minus xn into x minus xn minus 1. So this is the Newton's polynomial in backward differences operator form. So let's look at the data. We have x values and y values, which are 1, 2, 3, 4, 1, 6. When we name this data, we have x0, x1, x2, y0, y1, y2. So in backward differences method, what you have to do is call the last x as xn. So x2 is the last x, we are calling it xn. So when we call x2 equal to xn, this means that n equal to 2. So let's put this value n equal to 2 in our backward differences polynomial. So we have p2 of x equal to yn, but now n is 2, so we will put y2 plus backward y2 over h x minus x2 plus backward square y2 over h square 2 factorial x minus x2 into x minus n minus 1, n is 2, so 2 minus 1, which is 1. So now we have to plug the value of backward y2 and backward square y2, these differences. So we will have to construct the backward differences table. So the backward differences table will be, we have x values, y values. X values are 1, 2, 3, y values are 4, 1, 6. Let's construct the differences. Arrow between these two terms, 4 and 1. So you calculate 1 minus 4, which is minus 3. Between 1 and 6, arrow is, so you calculate difference between 1 and 6, but you calculate the difference like 6 minus 1, which gives you 5. Arrow between minus 3 and 5, you calculate the difference 5 minus 3, so you get 5 plus 3, which is 8. You have calculated the differences. Let's name the data. This third column will be named as del yk. Next column will be del square yk. Let's name the values x0, x1, x2, y0, y1, y2. This value will be backward y1. Next value will be backward y2. In the backward square yk column, the first value and the only value will be named as backward square y2. We have seen these notations in previous videos. Let's plug these differences, more specifically the value of backward y2 and backward square y2 in the polynomial. So we have p2 of x equal to y2. y2 here is 6 plus backward y2, which is 5, divided by h. h here is from the x values. So difference between 1 and 2, 2 minus 1, it is 1. Difference between 2 and 3, which is 3 minus 2, which is 1. So h here is 1. Into x minus x2. x2 is 3. Plus backward square y2, which is this 8, divided by h square is 1 square, which is 1, into 2 factorial, into x minus x2 is 3, into x minus x1, which is 2. Let's simplify this polynomial. So we have 6 plus 5, x minus 3, 8 by 2, which is 4, x minus 3 into x minus 2. You can verify that in this polynomial, if in the place of x you plug 1, you must be getting the corresponding y value 4, because for x equal to 1 in the data, you have the y value 4. The same way, if in the place of x you plug 2, you must get 1. If in the place of x you plug 3, you must get 6 for y. So this is how you can verify that your polynomial is correctly written. So you call this polynomial also f of x, also y. Now your y is 6 plus 5x minus 3 plus 4 into x minus 3 into x minus 2. So our question was here to find y dash at 4, where 4 is x. So first we will find the derivative here with respect to x of expression y. So when we differentiate y expression with respect to x, on left side we get dy by dx. On the right hand side we calculate the derivative of all the terms. Derivative of 6 with respect to x is 0. We keep 5 on the side, and the derivative of x minus 3 with respect to x. So derivative of x is 1 minus derivative of 3 is 0 plus 4 on the side, and now we have to calculate the derivative of x minus 3 into x minus 2 by using the product rule. So what does the product rule do? First term as it is multiplied by derivative of the second term. Second term here is x minus 2. Its derivative with respect to x will be derivative of x with respect to x is 1 minus derivative of 2 is 0. First term derivative, first term is x minus 3, its derivative with respect to x. Derivative of x is 1 minus derivative of 3 is 0, and the second term as it is. We have calculated a derivative of y with respect to x, which we are also calling y dash. Now we will simplify. 5 plus 4 x minus 3 plus x minus 2. So we have y dash So we have calculated the derivative of y with respect to x. Now we have to find y dash at 4. Meaning that in the place of x we will put 4. When we do that, y dash at 4 will be 5 plus 4, 2 into, in the place of x we have 4 minus 5. So we have y dash at 4 is equal to 5 plus 4. 4 to the 8, 8 minus 5 is 3. So we have 5 plus 12, which gives us 17. So first we constructed the polynomial y or p2 of x by using the backward differences method. Once we had the polynomial, we differentiated it with respect to x, and finally in the place of x we plugged the value 4 and we got y dash 4 as 17. So we are done with this problem.